Hey, this is Mrs. Davis. This is AP Calculus Lesson 8.4. This is the third video, and we just have a few more examples to go through. So for 6, it says find the bounded areas by the curves y equals ln of x and y equals 1/2 x minus 2. And so we're going to need a little sketch here. And let's say this is graphing calculator. Okay, and I wish I was there, or you were here to show you this with the graphing calculator, but here we go. There's your ln of x, and then 1/2 x minus 2 would be something like this. So they're talking about this area right here, all this area. So you can tell the natural log will be on the top, and the graph of y equals 1/2 x minus 2 will be in the bottom. But what you don't have is these intersections. A here and B here. And so you have to use your calculator, okay, to find the intersections, because you got to write them down for credit on a free response. So you're going to you're going to go to the graph, so you're going to do a graph, and you're going to put y equals ln of x in, and it'll show up, and then you're going to hit tab. Oh, is it tab? Hold on, I'm grabbing my calculator. Yeah, tab. And it lets you put another function in. So you have y equals 1/2 x minus 2. So those would be graphed together. Okay, and then you would go to menu, hang on, and it's 6, analyze graph, right? And then off of analyze graph, you would go to intersection, which is 4, and you go grab those intersections. And so what you're allowed to do, or what helps, because you can't shortcut this, you have to keep it the long letters, like out X number of decimals, not the long letters. So you can say that A is equal to, and you should have gotten 0.145555167, and B equals 8.2109333156. So when you're writing the work for this, even though you're going to do it on your calculator, you're going to do A equals A to B, as long as you identified A and B, and then ln of x minus 1/2 x minus 2. Again, don't simplify that at all, dx. Now that's enough work to count. So now what's really cool is you can go to your calculator, and you don't even need those intersections because it can do it for you. You go menu, 6, and then you want 8, bounded area. Okay, and so you're going to put your pointer right here at this A, and it'll say, like, I think it'll say intersection point when you're on the right thing, and you're going to hit enter. And then it'll ask for the other side, so you're going to move over and put your pointer on B. Again, I think it'll say intersection or something. And then you hit enter, and it will automatically display the area between that curve. So that's 8.784. So you can come in if you can't get that to work, and I'll show you how to do it real quick on your graphing calculator. And one more example before I close out the videos is that this comes up a bunch. It says, let R be the region bounded by the graphs 2 square root of x, so this is 2 square root of x, and x squared over 4. So those are the two areas. If the line x equals k, so right here, let's say x equals k, divides R into two regions of equal value, so this would be A and B, so you have to have A equal to B. What's the value of K? So we want to know where we would be on X. What X cuts area exactly in half? Question mark. Okay? So here's how you set it up. You don't need an A equals because you're doing two pieces, setting them equal to each other, setting piece A equal to piece B. So piece A would be 0 to K, and then you just do the area. So that would be 2 square root of x minus 1/4 x squared dx. And that is equal to K to 4 of 2 square root of x minus 1/4 x squared dx. Okay? And now you put this in solve. I suppose you could put it into the graphing calculator under the graph too, but it's easier to use solve. You're going to get 2 points because, believe it or not, this keeps going. Not believe it or not, but this keeps going, right? And we didn't do the domain out. So it'll happen again. The area will happen again where it's half. So it could be further on, or actually maybe in this direction. But we just want it to be the one that's between, it has to be between 0 and 4. So the answers were K is 1.764, and then you had K is 5.71348. And that's obviously not in our domain for our problem. So K would be 1.764. So that's how you do that one. The topic questions we'll be doing in class, so you may want to take a look at those and come in and get the answers for those. And then you have a practice to work on. Make sure you get used to sketching. You get really good at sketching after you do a whole bunch of these. All right.